Stoichiometry. What is stoichiometry? Stoichiometry deals with chemical reactions. It deals with looking at a chemical reaction and figuring out how much of the reactants you need to make the products you want. So again, it's kind of like an analysis of a chemical reaction, a quantitative analysis of how much of these things you need here to make that over there. So here's an example of a chemical reaction you might see at a bonfire. 2 graham crackers plus 1 marshmallow plus 4 chocolate pieces can make 1 s'more. So this would be considered our chemical reaction. On the left side here we have our reactants. Our reactants are graham crackers, marshmallows, and chocolate pieces. They can make s'mores. The numbers you see in the front, the 2 and the 1, the 4 and the 1, we call those coefficients. And they basically tell you how much of that you need. Think of it like a recipe. A recipe will tell you how many eggs, how many cups of flour or cups of milk you're going to need. And so the coefficients are the number you need. So this is what stoichiometry deals with. So let's ask yourself a question then. If I want to make more than 1 s'more, for say, let's say you're having a big party and you want to have 10 s'mores. You're going to have 10 friends and you want to have 10 s'mores to eat. Well, how much of this other stuff will you need to make that happen? Every single s'more requires 2 graham crackers. So how many graham crackers do you need to make 10 s'mores? Well, 2 makes 1, so we'll need 20 to make 10. Again, one marshmallow will meet the needs for 1 s'more, so how many marshmallows do you need? Well, it's just a 1-to-1 ratio, so if we have 10 marshmallows, we can make 10 s'mores. How many chocolate pieces do I need? It takes 4 chocolate pieces from the balanced chemical reaction from the recipe to make 1 s'more. So we're going to need a 4-to-1 ratio. We'll need 40 chocolate pieces for everybody to have a s'more. So again, this is just an example of a real-life thing you might encounter when you got to buy ingredients for you and your friends. Now, in the chemistry world, we look at chemical reactions, and this is where it gets scary. But again, it's the same kind of process. Just we have here we have cellular respiration. 1 sugar molecule requires 6 oxygens. Again, this is my coefficient right there. There's 1 sugar that needs 6 oxygens to be combusted. And that turns into 6 carbon dioxides and 6 waters. So stoichiometry looks at this relationship here and how these things relate to each other. So, if you have, for example, 36 oxygens, how many sugars can you burn? Well, 36 over 6 equals 6. And every single one of these requires 6. So we're going to be able to fully combust 6 sugar molecules. So that's again what stoichiometry is. Stoichiometry deals with chemical reactions and how much it takes of each one, just like a recipe, to make the full reaction take place.